10.5 today, last section of probability and also the last section of notes that we're going to be covering until after you guys take your EOC. So last section of notes for a while. Now, with it being the last section, a lot of times it's easier, sometimes it's harder. Today, hopefully, if you've had a good grasp of what we talked about the last couple days, this is going to be easy and the notes are quite a bit shorter. So hopefully it's a good day for you to enjoy a nice, easy day of notes. Today we're going to be talking about independent and dependent events. Now, independent events. What does independent mean? If two things are independent, they do not rely on each other. That's what independent is versus dependent. They do rely on each other. So when we're talking about independent events, one outcome has no impact on the other. Okay, so one outcome has no impact on the other, or one event has no impact on the other event. That's why it's independent. Now, an example, you toss two coins. Does it matter what happens in my first coin toss if I have a second coin that I'm tossing? Two different coins, two different tosses, one has no impact on the other. Now, the probability of these independent events. This is what the notation looks like. It's almost like an upside down U. Don't let notation confuse you. We've talked about that before in the past. Don't let the notation or the math symbols confuse you. This notation is a notation for and. Okay, so this is a probability of two events occurring. So if it's an and probability, what do we know? We have to multiply. So the probability of A times the probability of B. Now over here it says this can work for 3 or more events as well. Okay, just saying that we can go as far as we want into this. We don't have to have two things. We could be tossing 3 coins or 4 coins or 5 coins. It doesn't matter. So as many events as we have. So I have a spinning wheel over on the side with colors. Kind of reminds you of Wheel of Fortune for those of you who know what that is. The example says find the probability of spinning a red then a yellow. Okay, well, what's my probability of spinning a red? I have how many red sections? 1, 2, 3. But when I talk about probability, how do I write this out? It's possible, or what you want, over, what goes on the bottom? When you're talking about probability, it's always over the total. So I need to go around and count my total. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what's my probability of getting a red? Red is 3 over 16. What's my probability of getting a yellow? Yellow is 5 out of 16. And why are we multiplying these? They have nothing to do with each other. Red is 3 out of 16. Yellow is 5 out of 16. I want to spin a red, and then I want to spin a yellow. So this is an and question. Okay, so all you're doing is multiplying. 3 out of 16 times 5 out of 16 gives you 15 out of 256. Or, remember we said we can write these as fractions. You can write them as decimals. It doesn't matter when it comes to probability. So, as a decimal, this would be 0.05859. How about the probability of spinning a yellow than a red? Well, we just kind of talked about this one. It's just backwards. What's the probability of a yellow? 5 out of 16. What's the probability of a red? 3 out of 16. And I want to spin a yellow and then a red. So this is still multiplication. So is the answer going to change? Even though we went from red to yellow and then yellow to red, since this is and this is multiplication, we get the exact same answer. So your probability does not change. Now, dependent. What do we say about independent? Independent means there's no effect. They are independent of each other. But if it is dependent, the occurrence of one is going to affect the occurrence of the other. That's why it's called dependent. There's an effect on it. Now, an example. You draw a card from a deck, but then you keep it, and then you draw another. that's going to completely change everything, because if you draw a card and keep it, you started out with 52 cards, but after you keep it, now you only have 51 cards. Okay, so the first outcome or the first event had an effect on the next one. You're going to go from 52 cards down to 51. Okay, these are our dependent events. Now again, don't let the notation confuse you. This upside down U just means a U, or just means and. And same thing here, don't let the notations confuse you. Probability of A times, so it's still multiplication because we're still dealing with and probabilities. And this notation over here, it says it's the probability of B given that A has happened, or your conditional probability. So that's the probability as we go through the problem, or the probability as it changes. Our example up here would be, we started with 52 cards. Okay, so that would be part of probability of A, but then if we keep that one card, then the second probability is only at a 51. That's our conditional probability. What happens as we go through the process, as things change? Okay, that's our conditional probability. So a couple examples. Find the probability of drawing the given cards from a standard deck, and we're going to do this two different ways. We're going to do this with A, with replacement, and B, without replacement. Okay, so A with replacement. What's the probability of drawing a spade? Well, a spade is one of the suits, right? So there's 13. Then a club. How about a club? There's also 13. And we're talking about probability, so it's always what you want over the total. So how am I going to write this out? Probability of drawing a spade is 13 out of 52. Now I'm doing A, so it says with replacement. So I draw a spade, I put it back in the deck. That's what with replacement means. So 13 out of 52 times, so what's this going to be? Drawing a club is 13 out of 52, because whatever card I drew right here is going back in. So it's just 13 out of 52 times 13 out of 52, which is 1 over 16, or 0.0625. And again, fraction or decimal, does not matter. Now, without replacing, that means you keep it. So if I'm going to keep it, I'm now talking about a dependent event, because if I keep it, that's going to change the number of cards that I have in my hand. Okay, so let's start with the spade again. Is the spade going to change? We said drawing a spade was 13 out of 52. That was this first one. Is that going to change? No, it's still 13 out of 52. But now when I talk about without replacement, this dependent event, I take a spade out of the deck. That's what this is doing right here. I'm drawing a spade. So if it's without replacement, if I do not put that spade back, what are my chances of drawing a club going to look like? There's still 13 clubs because I drew a spade out. So there's still 13 clubs, but are there still 52 cards in the deck? Now there's only 51. And again, that's that conditional probability. There's 13 clubs, but only 51 cards in the deck because I kept the spade that I had. So 13 over 52 times 13 over 51 gives you 13 over 204 when it's reduced, or 0.063725. Okay, so similar example, except a little different now. Probability of getting a face card. How many face cards? Jack, Queen, and King. 4 suits, so we have 12 out of 52 face cards. And we're doing A, so with the replacement. So we put whatever we draw, whatever face card we draw, we put it back in the deck. So then what's the probability of drawing an ace? How many aces? 1 in each suit, so 4. And we put that face card back in the deck, so this is 4 out of 52. Multiply those, reduce, they give you 3 over 169. Or as a decimal, this is 0.01775. Now, the same question except without replacement, okay? So this time after we draw, we're not putting it back, without replacement. So does the first part change? Drawing a face card. Drawing a face card is still 12 out of 52, but I don't put it back this time. So if I don't put it back, what are the chances of me drawing the ace? 4 out of 51. So 12 out of 52 times 4 out of 51 reduced is 4 over 221, or 0.018095. Okay, so a big difference when we talk about that conditional probability, that probability when we're not putting cards back in these situations. Okay, so always look for that conditional probability. So the next one, same questions except 2 more examples. I want to draw an ace. Okay, one ace is what? 4 out of 52. A is with replacement. So I draw an ace, but what do? I put it right back. So if I put it back in the deck, what's my chances of drawing another ace? 4 out of 52. Because the one that I drew, I put back in. So there's still 4 aces in the deck. So 4 out of 52 times 4 out of 52 reduced is 1 over 169, or as a decimal, 0.0059. Okay, again, conditional is going to change without replacement. So with this conditional probability, 4 out of 52 are still my chances for drawing the first ace. But now, without replacement, if I don't put the ace back, I have how many cards? I have 51 cards. But I didn't put the ace back, and I want to draw another ace. So what's this going to look like? It's not going to be 4 out of 51. It's going to be 3 out of 51. Because the one card that I took from the deck to make this 51 cards was an ace. So I don't have 4 aces. I only have 3 aces. So 4 out of 52 times 3 out of 51 is 1 over 221. Or 0.0045. Okay, again, very similar, but now in this last one, we've got 3 different cards that we want to draw. So drawing a 2, what are my chances? What are my odds? Got 4 of them, so 4 out of 52. Okay, we're doing A, so everything is going back in the deck with replacement. So I put the 2 back in the deck. What are my chances of getting a 3? 4 out of 52. I put the 3 back in the deck, so what are my chances of getting a 2? 4 out of 52. So we multiply those out, and we get a 0.00046 probability. Now, just so we understand with our heads, a lot of us like percentages, so if I move this over 2 decimal places, this is still 0.046%. That's a very low probability. Okay, just so we kind of remember, you can go back and forth between those. Okay, so 0.00046 is a very low probability. Okay, same question, but now without replacement. So whatever we take, we keep in our hand. Okay, so we draw a 2, so 4 out of 52. We keep that 2 in our hand. So then what's the probability of drawing a 3? 4, I've got 4 of them, but only out of 51. I kept the 2. Now this next one, be careful when you write it down. I want to draw another 2. What are the 2 cards I have in my hand? I have a 2 and a 3. So when I go to draw a second 2, I don't have 4 of them. I only have 3 of them. And I have 2 cards in my hand, so it's 3 out of 50. So 4 out of 52 times 4 out of 51 times 3 out of 50 gives me a probability of 0.00036. Okay, so that with replacement, without replacement, that conditional probability. Okay, it makes a big difference when you're talking about probability, whether or not the first event has an effect on the second event. Okay, so again, make sure you're looking for things like that when you talk about probability. So here's your homework, not very much. And again, this is the last section for probability, last section for Chapter 10. Now all we've got for the next week or so is our preparation for our EOC. Okay, so make sure you work hard when we're talking about this preparation for EOC this next week or week and a half, because you won't have notes for the next week or week and a half. It's just practice and preparation. So making sure you're getting yourself ready.